What if I told you it's not what you know about the cardiac cycle that gets you mark? Rather, it's how you present it. Most of our university examinations don't reward information overload, but they reward clarity, structure, and smart presentation. So today, this isn't just another lesson on the cardiac cycle, but you are going to learn something more powerful about the psychology of writing an answer that score full marks. Okay, so let's take the cardiac cycle and turn it into a perfect examiner friendly answer. This is the final answer that you're going to write about the basic concept, definition, introduction, and then all the phases of the cardiac cycle in a flow chart, main content of the answer. As long as a question, you're going to draw two diagrams about the cardiac cycle, phasic diagram, and this pressure and volume curves. And last but not the least, about a heart sounds and the applied physiology. So let's write it together. If you copy this answer exactly same, I guarantee you that you will get out of out marks in your university examinations. For a long essay questions, you need to write the answer under 5 headings: introduction and definition, main content, diagram, applied physiology. So let's start. First, the introduction and definition. About the basic concept. Heart, it acts as a two separate pump in series, right for the lungs and left for the peripheral organs. To act as a pump, it shows systole, that is a contractile phase, diastole, that is a relaxation phase. And here comes the definition of a cardiac cycle. It is electrical and mechanical events from the beginning of one heartbeat to the next. This is the very important part of the answer because it carries 1 marks. For ECG and mechanical event correlation, you are going to draw this ECG. It shows P wave, that is atrial depolarization followed by atrial contraction, QRS complex ventricular depolarization followed by ventricular contraction, and T wave ventricular repolarization followed by ventricular relaxation. To find out the duration of the cardiac cycle, it is calculated from the heart rate. If the heart rate is 75 beats per minute, that is in 1 minute 75 cycles, so one cycle takes about 0.8 second. This is a very important part, so you need to write it. Here comes the phases of the cardiac cycle. It having atrial cycle, that is 0.8 second, atrial systole of 0.1 and atrial diastole of 0.7 second, and ventricular cycle of 0.8 containing ventricular cycle of 0.3 and ventricular diastole of 0.5 seconds. Remember, both the sides of the heart pump the same volume of blood over time. Again, here you are going to draw very important diagram of phasic changes. It containing 3 concentric circles. The inner circle shows the atrial systole for 0.1 and atrial diastole of 0.7, and the outer circle shows ventricular systole for 0.3 and ventricular diastole for 0.5. This is very important part of the answer because it carries 1 mark. After the phases of the cardiac cycle in a flow in a diagram, here we are going to write in detail about the flow chart. Now, this phases of the cardiac cycle includes atrial cycle as well as ventricular cycle of each 0.8 second. The ventricular cycle is further given as ventricular systole and ventricular diastole. Ventricular systole for 0.3, it is broken down into 2 parts, that is isovolumic contraction 0.05 second and ventricular ejection of 0.25. It is having 2 parts, that is rapid and slow ejection phase of 0.1 and 0.15 second. Ventricular diastole for 0.5, it is having 5 parts, that is a protodiastole, isovolumic relaxation, rapid passive filling phase, reduced filling or diastasis, and last a rapid filling phase, which coincides with the atrial systole. So after this, main part of the answer starts because it carries 2 marks. Let's write it. It consists of atrial systole, which is about 0.1 second. It coincides with the last rapid filling phase because and second one is the atrial diastole. Before the atria contracts, 75% of the blood is already coming into the ventricles because of the gravity. This atrial systole gives about 25% of the blood into the ventricles. What is the effect of this atrial systole? First effect, it increases intraatrial pressure. Right side 4 to 6 mm of mercury, whereas left side 7 to 8 mm of mercury, and it also produces A wave in a jugular venous pulse. Second part is atrial diastole. It coincides with the ventricular systole and most of the ventricular diastole, And when the atria are relaxing, continuous venous return causes gradual filling of the aorta. One point here important to write about the atrial kick, that atrial contraction gives only 25% of the ventricular filling. As a student, you should note that no long paragraphs we are writing here, only important headings and the point wise which are shown as the. Continuing with the main component, ventricular systole, which is about point 3. It is having two phases, phase of isovolumic contraction and phase of isovolumic contraction. Here the ventricle begin contracting and the pressure increases more than the atria, so the AV valve closes, which produces the first heart sound. As the seminal valves are not yet open, so the ventricle contracts as a closed chamber, and this produces C wave in JVP. The second phase is the ventricular ejection. Here the left ventricular pressure starts rising more than the aortic pressure, that is 80 mm of Hg, and right ventricle more than the pulmonary artery, that is 10 mm of mercury. Now due to this, the seminal valves open and that lead to the ejection phase. It shows two parts: rapid ejection, ejecting 2/3 of the stroke volume, and slow ejection, ejecting 1/3 of the stroke volume. Now what is the stroke volume? So amount of blood ejected per beat is 80 ml. And the end diastolic volume is about 30 ml. So the amount of blood which is remaining at the end of the systole, that is end systolic volume, about 50 ml. And this gives us ejection fraction which is about 65% of the end diastolic volume. Most of the students do this mistake of writing an answer in a paragraph. So here a very important point to remember: no long paragraph answer. Here the ventricular diastole. It is having 5 phases. First phase is protodiastole. Here the ventricles start relaxing and the intraventricular pressure falls rapidly. Because of this, the blood in the aorta and the pulmonary artery pushes backward, and it causes the seminal valve snap shut and produces the second heart sound. It also causes the dicrotic notch incisura on the aortic pressure curve. The second phase is isovolumic relaxation phase, about 0.06 second. Here the seminal valve closes and the AV valve is not yet open, so ventricle relaxes as a closed chamber. The effect is the pressure decreases from 80 to 2 to 3 mm of mercury. Since the volume remains constant, this phase is called as isovolumic relaxation phase, and this phase is responsible for V wave in JVP. One point important to note here, that right ventricular ejection begins before left ventricle and the aortic valve also closes before pulmonary valve during inspiration. Next, about the ventricular diastole. Again, see here that most of the answers or explanation written under the arrows own complete sentences. So this mistake you should avoid. So last 3 phases of the ventricular diastole: rapid passive filling phase. Here the AV valves open and the blood inrush from the atria into the ventricles, and because of this it produces the third heart sound. Next phase is the reduced filling phase or diastasis of 0.19 second. Here the pressure in the atria as well as the ventricles equalizes and now the flow becomes slow and smooth. And at the end we are having last rapid filling phase of 0.1. As we have seen, it is coincide with the atrial systole and it gives only 25% of the blood into the ventricles, and this produces the fourth heart sound. After the phasic changes, here comes the second part of the answer, that is the pressure and volume changes. So let's start with it. The key ventricular pressure change, atrial pressure change, and aortic and pulmonary pressure. To describe this ventricular pressure, we need to draw this Veiger's diagram, and this part shows the ventricular pressure change. As you can see, pressure in the left ventricle during diastole it is about 8 mm of mercury, and during isovolumic contraction it changes from 8 to 80. During ejection it becomes 120. After ejection it comes back again during isovolumic relaxation stage to about 8 mm of mercury. The same changes takes place in the right ventricle, but the value is about 25 mm of mercury. After this, about the atrial pressure. For atrial pressure, we are going to explain in the form of JVP, jugular venous pulse tracing. So here we are going to draw this JVP tracing having 5 waves: A, C and V waves, that is 3 positive waves and 2 negative waves, X and Y. A is showing atrial systole, C for ventricular contraction and V for ventricular filling, whereas 2 negative waves X and Y represent atrial relaxation and AV valves opening respectively. And the third part is aortic and pulmonary pressure. From this Wiggers diagram, this part shows the aortic and pulmonary pressure changes. As you can see, aortic pressure varies from 80 to 120. During diastole, the pressure is 80, and during ejection, it changes to 120 and again comes back to 80. And this is responsible for the diacritic notch, that is incisura, caused by the backward collision of blood when the aortic valve snaps shut. So this is how your finally pressure diagram should look like. It's showing three pressure changes: left ventricular pressure changes, below the atrial, and above the aortic pressure changes. If you understand this, you already scored half of the marks. After this pressure changes phasic diagram, below you are going to draw the volume changes diagram, and this is the must draw diagram. As you can see from the diagram, the amount of blood which is remaining in the ventricle, that is the end diastolic volume, is about 130 ml, which gives a stroke volume of 80 ml, and the amount of blood which is remaining in the ventricle at the end of the systole, that is end systolic volume. And this ratio of stroke volume to the end diastolic volume gives us ejection fraction. This diagram along with this explanation is most examiner's favorite. A short note about the heart sounds. You are going to write the first heart sound and second heart sound in a tabular format as shown here. The cause of the first heart sound is closure of the AV valves. Second heart sound, closure of the seminal valves. First heart sound, start of the ventricular systole. Second heart sound, start of the ventricular diastole. Character of the first heart sound is long, soft and low pitch. Second heart sound, short, loud and high pitch. First heart sound sounds like a lub. Second heart sound sounds like a dub. Duration and frequencies 0.15 and 25 to 45 Hz. Second heart sound 0.12 and 50 Hz. First heart sound coincides with the peak of R wave. Second heart sound coincides with the end of T wave. And first heart sound best heard over the mitral and tricuspid areas, whereas second heart sound best heard over the aortic and pulmonary area. This diagram shows the location of the areas for your reference. Then the third and fourth heart sound, these are called as silent heart sounds because they cannot be heard with the help of stethoscope. The third heart sound is because of rapid passive between T and P wave, whereas fourth heart sound is because of atrial systole, that is last rapid filling phase. It comes between end of P and beginning of Q wave. And lastly, about the cardiac murmurs. It is abnormal heart sounds produced by the turbulent blood flow. The causes of the cardiac murmurs are valvular stenosis, valvular insufficiency, septal defects, and coarctation of aorta along with the patent ductus arteriosus. Now here comes the last part of the answer, and that is the applied physiology. It's very important, so because it carries 1 mark, you need to write it. If tachycardia occurs, the total duration of cycle decreases. For example, if heart rate is 75 beats per minute, duration is 0.8. If changes to 200 beats per minute, duration of the cardiac cycle becomes 0.3. As you can see, it includes systole as diastole, duration of both decreases. But most important, the danger here is the duration of the diastole decreases much more than the systole, and which gives our clinical implication, because coronary blood flow occurs only during diastole. As the heart rate increases, less perfusion time, and there is a risk of myocardial ischemia. This line gives you extra edge over the others. And second implication of the increased heart rate is ventricular filling occurs mainly during diastole, and that causes poor filling, cardiac output falls, and that lead to the heart failure symptoms. So congratulations for successfully writing this long essay question of cardiac cycle along with me. As you can see, we have written about the basic concept, definition of the cardiac cycle, then about the phases of the cardiac cycle in the form of flow charts. For main content, we have drawn the two diagrams. First about the phasic changes, second about the pressure and volume changes. Also, we have written a short note on the heart sound, and last but not the least about the applied physiology. So revise this once before the exam and then you are done. Please let me know in the comment box out of these topics which topic you want next: cardiac output, blood pressure regulation, neural regulation, or carbon dioxide transport mechanisms. Please do subscribe, and all the best.